afternoon, good evening, good morning, EL 120 students. This is your friendly hillbilly professor again. Um, we're going to dive right back into 300, Article 300. We're going to look directly at underground installations. So, as an electrician, one of the biggest things that we do a lot of is we dig in the dirt. We get things from point A to point B. For example, you've got a house that you live in and you have a detached garage. Well, in order to get it from one point to the other, you have two options. You can either go overhead or you can go underground. Well, a lot of times people are going to want to be able to put it underground. Well, there are specifications you have to go off of to be able to understand how deep to bury this, to be able to make it to code. These are for a multitude of reasons. If you bury it too shallow, somebody's going to be able to come through as they're digging. If you sell the home, they start trenching, well, they're going to rip something out. So these are designed as a baseline of where they want things buried per the National Electrical Code. And trust me, electrical inspectors will test this. They will look for this. So right off the bat, let's look at 300.5 underground installations. Okay. It says, and let me expand this. Whoop, that's not what I wanted. So minimum cover requirements. Direct burial cable, conduit, and other raceways shall be installed to meet the minimum cover requirements in Table 305.A. And this is Table 305.A. We're going to expand it out. And man, it's got a lot of stuff on here, right? It's got column 1 for direct burial cables or conductors. That's just wires that you'd actually directly bury in the ground. You got a column for just rigid metal conduit or unrated conduit. You got a raceway, EMT, non-metallic raceways, direct burial without concrete encasement and other approved raceways. Then you got branch circuits, 120 volts or less, uh, maximum current protection 20 amps. Circuits for control irrigation and landscape lighting, not more than 30 volts. And then we have these inches deep, so we have these millimeters. Again, as we're in America, we try to concentrate on this section, as it were, of it. Whoop. Again, we try to concentrate on this section. See, and not, I'm not, it's not liking me today. Here we go. We're looking to stay on the inches burial depth. Depth, I love it. Um, so we can look at this and we can say in a trench that's to under 2 inches of thick of concrete, that means 18 inches. Okay, for these type of guys. If it's rigid metal conduit or IMC, number 6 is 6 inches. You know what, Mr. Scott? That's just a bunch of crap. What does that really mean in life? Well, guys, let me show you. Here's another way to be able to take a look at this. Okay, underground, this is another chart. This is basically what I understand it. Under the earth, okay, under dwelling well in a dwelling unit, driveway, or parking area. Okay, if it falls under column 1, UF underground feeders or US underground service entrance cables, they're going to be 18 inches deep. Okay, rigid metal conduit, 18. 18 for non-encased. Residential stuff, you can be 12 inches. Okay, less than 20 amps. Under a roadway, calling for 24 inches for these different things, all the way through for the non-metallic raceways. If it fell on column 3, and then your other locations, right? Well, that's good and all, but that's just another chart, Mr. Scott. What does that look like? This is what this means. Okay, your rigid metal conduit, on average, for this 6 inches under this right here. This is where they're talking about the reference for 6 inches burial. Okay. So this is kind of an example of your 6, your 18, and 24. Want you to point out to you, the arrows, they're talking about the top of the conduit. That means that if you're running a 2-inch conduit underground, your cover above it needs to be, um, let's see, we're running PVC, needs to be 18 inches. So that means that your depth of your ditch doesn't need to be 18. It needs to be at least 22 for a 2-inch conduit. So you have to have that much burial and clearance above it, okay, to what you got to have. Uh, and that was what that table 300.5a really deals with, about the distances, how deep it needs to be. Okay. Um, so that was talking about A, minimum cover requirements. Well, 305's got a second part that's got a B to it. And it's got C and D, and with subsections for every one of those. Okay, the main points I want to be able to talk about, there's this table to be able to reference back to. And then wet locations, B. The interior of enclosures or raceways installed underground shall be considered to be a wet location. Insulated conductors and cables installed in these enclosures and raceways and underground installations shall comply with 310.10c. Well, what does 310.10c say? Well, it says insulated conductors and cables used in wet locations shall comply with one of the following: be moisture impervious metal sheathed, be types of the following. Standard that you're going to see is THW2, THHW, THWN, THWN2, XHHW, and be listed, okay, for those use in locations. All right, Mr. Scott, again, this is one of those, what does that mean? This is what it means. Per 300.5, if you've got a box in the ground, okay, and you have conductors coming up into it, not only your cables must be approved for wet locations, but your splices. Can't just be a regular wire nut. It needs to be a wet location splice inside of these boxes. A lot of times, that people don't do that. And what happens is these regular wire nuts will deteriorate in water, uh, because of the heat, the temperature, and everything else, and they'll just fall apart. And what you have in these boxes are open joints or open connections. And if somebody opens it up, it's going to shock them. It's a potential for, if it doesn't open up and that fails, well, there's a potential for failure and a short to be able to start tripping the system. Now you have nuisance tripping potential. That's what that particular means. So let's talk about 300.5c, underground cables and conductors under buildings. Underground cable and conductors installed under a building shall be in a raceway. Okay. There is a couple of exceptions. Type MI cable shall be rented under a building without installation in a raceway where embedded in concrete fill, or masonry, according to 332.10.6, or in underground runs were suitably protected against physical damage or corrosive conditions, and according to a different article. So what does that mean? Well, let's go back over our handy dandy little whiteboard and see if we can't find out. It's just basically saying, under your building, it's got to be in a raceway. There's a piece of conduit sitting right there, unless it falls under those exceptions. It's just smart not to put a buried cable under your house, because your house settles, things move. It could get damaged and have a short potential. Down and dirty. So let's talk about protection from damage. Okay. 300.5d talks about conductors and cables shall be protected from damage in accordance with 305d1 through d4. So you got 4 different instances that they're talking about that you need to be able to fall under. So when it emerges from grade, direct burial conductors and cables emerging from grade, specified in column 1 and 4 of the table, shall be protected by enclosures or raceways extending from the minimum cover distance below grade required in 300A or 305A to a point at least 8 foot above finished grade. In no case shall the protection exceed 18 inches below finished grade. Be required to exceed. It's not required. You can take it deeper, but it's not required. So conductors entering into buildings, conductors entering the building shall be protected by point of entrance. Now here's what I want to point out to you. This is why you have to do a specific thing when you do underground. Underground service conductors that are not encased in concrete and that are buried 18 inches or more below grade shall have their location identified by a warning ribbon that is placed in a trench at least 12 inches above the underground installation. Okay, well let's look at a real world. This is what this looks like. We're talking about you've got a service entrance conductors coming in here, whether it be in concrete or whatever, and then 12 inches below above that, you've got to have your ribbon tape. And that ribbon tape, as people dig across, they see it, there's an indication that, hey, there's some power here. Okay, so we're going to move on just a little bit. We're going to run through here. Let's talk about the backfill. We're still in 300.5, just the underground installations. These guidelines, we've already covered some of this other stuff. Let's look at backfill. So backfill, let's go back to this. We're talking about anything that would be going on top of our service entrance conductors or anything that we're buried underground. Okay, you can look here at these pictures and there's some pretty good sized rocks in there. Okay, well the NEC covers that. It says backfill that contains large rocks, paving material or cylinders, large or sharply angular substances, or corrosive materials shall not be placed in an excavation where materials might damage raceways, cables, conductors, or other substructures, or prevent adequate compaction of fill, or contribute to corrosion of raceways, cables, and other substructures. Where necessary to prevent physical damage to the raceway or cable or conductor, protection shall be provided in the form of granular or selected material suited running boards, suitable sleeves, or other approved means. Well, let's go back to our picture here again. We're talking about this backfill. Okay? If it was greater, bigger, if it was junk off the job site, none of that needs to be in the ditch at all. Okay? Raceway seals. Conduits or raceways through which moisture might contact live parts shall be sealed or plugged at either or both ends. Spare or unused raceways will also be sealed. Sealants shall be identified for use with cable insulation, conductor insulation, bare conductor, shield, or other components. Basically, what this one means is if you have spare conduits, they're supposed to have a plug in them or supposed to have a cap on. That way it doesn't leak in water coming into buildings. I've seen spare pipes coming into vaults that had equipment inside of it that would just gather water and the humidity, and it would just seek inside or sneak inside and short the equipment out. Okay. A bushing or terminal fitting with the integral bushing opening shall be at the end of conduit or the raceway that terminates underground, where the conductors or cable emerge as a direct burial wire method. A seal incorporating physical protection against characteristics of bushing shall be permitted to use in lieu of a bushing. Okay. Let's go on down here to J. Where direct burial conductors or raceways or cables are subject to movement by settlement or frost, direct burial cave conductors, raceways, or cables shall be arranged so as to prevent damage to the enclosed conductors or the equipment connected to the raceways. Okay, so what this is talking about is you can put an S down below the ground, basically a coil of wire. Let's get back over here to my whiteboard. If you had a underground trench and you had a conduit coming up We'll use this funny color right here. Let's consider that a conduit, shall we? And we're down here, and this thing extends down below grade just a little bit. Okay. Well, due to expansion and contraction between the earth above and the sunlight up here, and the cold earth and the warm earth and the outside temperatures, the earth moves up and down just a little bit. So, what they're talking about in this code is if you had a wire underground, before you bring it up into this conduit, you need a little S. And then you can bring that guy up into it. That compensates for the wire itself and the movement that you're potentially going to get right there. Now, there's another caveat to this, okay? There's a thing called expansion fittings. That's what these are right here. These are the part that you put above ground, okay, per ground movement here, that you have to put per the code to be able to compensate for your conduits. Because if you're coming underground with conduits, they're not going to have a give up and down, even if it's PVC, and that's going to separate your conduits. So basically, what you'll be having to do is these slip in on top of each other and compensate for the ground moving up and down. So these are expansion fittings, okay, that you need to be using. You'll use these expansion fittings here. You'll also use these expansion fittings later on. They'll talk about when you cross expansion fittings and expansion joints in buildings. You're supposed to have a expansion fitting in your conduit to be able to allow movement in these buildings, even the buildings move just a little bit. All right, team, here's what we're going to do. We're going to go ahead and bounce over to Article 310, okay? And we're going to talk about the conductors for general wiring. We're talking about the wires themselves, how they're made, what they're made of, what will allow, what the code will allow, their markings, their ampacity ratings, and where they're allowed to be used. So let's talk about the scope right off the bat. When you start any of these things, you need what the scope of the article was. So the Article 310.1. So scope. The article covers the general requirements for conductors rated up to and including 2,000 volts, and their type designations, their insulations, their markings, the mechanical strengths, ampacity ratings, and uses. These requirements do not apply to conductors that form an integral part of equipment such as motors, motor controllers, similar equipment, and conductors specifically provided for elsewhere in this code. We've seen this before. Okay, we're talking about manufacturer developed equipment. Okay, so let's dive in. 310.3. So I guess they took out 2 at some point. Minimum size conductors. The minimum size conductors for voltage ratings up to and including 2,000 volts shall be 14 AWG copper or 12 aluminum copper or copper clad aluminum, except as permitted elsewhere in this code. Okay. The material. So it's talking about the minimum size. Now we're going to talk about what it's made of. Conductors in this article shall be of copper, aluminum, or copper clad aluminum unless otherwise specified. Aluminum and copper clad aluminum shall comply with the following. And here's are their designations for what they what they have to comply with. Now, I don't use aluminum. Okay, sometimes you will. A lot of places don't even allow it anymore. Sometimes you'll use it for service entrance, but not on the inside of the house. So make sure you're checking with where you're at with what's legal and what's not. This one right here, C, 310.3C, is one that you need to be able to kind of put in your mind because it's one of those things that it's a code question people ask. When installed in raceways, conductors 8 AWG or larger shall be stranded unless specifically permitted or required elsewhere in this code to be solid. Okay. Conductors 8 American gauge or 8 gauge or bigger shall be stranded. D. Insulated. Conductors not specifically permitted elsewhere in this cover to be covered or bare shall be insulated. So unless it says somewhere else in this code that you can have a bare wire, it's got to be insulated. You got to be able to reference that. Okay. So let's talk about the construction specifications. This is a table that you will inevitably, okay, um, you inevitably will have to go back to. At some point, some person's going to ask you, give me the properties of a THHN. Well, where to go? This is where you actually get the information for that. Okay. So for example, this is how you read this table. Okay. You go down through here and you find the type of wire. So for example, let's find THHN, which is our standard type of wire, right? That's what we use more than anything else in the trade. So that tells us, if we remember, that our trade name, type of letter, okay, maximum operating temperature, application provisions is where you can use it, where you can't use it, or where you can use it, where it's allowed. The insulation gives you the type of insulation here. The thickness of the insulation per the gauges. Okay, and I have asked questions for sure asking you what the mils in thickness of insulation, and this is where you go to find that. Okay, and then it closes out with the outer covering. Okay, so let's look at THHN. Well, I passed it, didn't I? So it's heat resistant thermoplastic. Okay, we call THHN, 90 degrees. It's good for damp and wet locations. Okay, it's flame retardant, heat resistant thermoplastic. It's got a nylon jacket, so has an additional thin jacket on the outside of it. Okay, and from 14 to 12, that outside thickness is 15 mils. Okay, it's that simple. You inevitably will have to over and over again go back and look at this to be able to see where things are actually allowed to be, okay, and what their maximum operating temperature is. So you may get into some situations where you have some very high temperature stuff. So you have to find something that's going to fit in a high temperature location, which could very well be this Porfirio Alioxy PFA. So let's continue on down, and there's another chart that talks about conductor identification. Okay, conductor identification. Insulated or covered grounded conductors shall be identified in accordance to 200.6. Okay, what does 200.6 say? The insulation of grounded conductors of 6 AWG or smaller should be identified by one of the following means. A continuous outer water finish, continuous gray, 3 white or gray stripes along conductor, conductors with water gray insulation, color tracer, all of these things right here. Okay. Grounded conductors. We're talking about intentionally grounded conductors. That's going to be your neutrals. Okay. That is my grounded, intentionally grounded, because it is grounded at the first means of disconnect. Okay. Your equipment grounding conductors, now let's talk about the colors there. Your equipment grounding conductors, what does 251.19 reference us back to? Well, let's talk about to be bare, covered, and insulated. Okay. Continuous outer finish, green or green with one or more yellow stripes. Conductors insulated with green with one or yellow stripes. So it's telling us to go back to, hey, we need to put these grounds in this particular configuration. So now we've covered our grounded conductor, which is our neutral, our equipment grounding conductor, which is what is our ground itself through the system. Now we're talking about our ungrounded conductors. Okay, our ungrounded conductors, those are intended for use as underground conductors. Those are your hots, guys. That's where your voltage is carrying through. Your neutral carries it back, where your voltage is being carried through on your ungrounded conductors. So it says conductors that are intended for use for ungrounded conductors, whether used as a single conductor or multi-conductor cable, shall be finished to be clearly distinguishable from grounded conductors and equipment grounding conductors. Distinguished markings shall not conflict with any manner with the surface markings required by this reference 310.8b1. Branch circuit ungrounded conductors shall be identified in accordance to 210.5c. Feeders shall be identified in accordance to 215.12. Marking. Okay, this is important. These wires have got to be marked. They have all conductors and cables shall be marked to indicate the following using the applicable method: the maximum rated voltage, the proper type or letters, the type of wire it is, the manufacturer's name and trademark, the AWG size, or in circular mills. Guys, that comes from the factory that way. And here's an example of what that looks like right here. Okay, 600 volt rated. Okay, for CTUs, SR, XL, its type of wire is an XHWN2, and the size is 250,000 mils. Okay, and we'll get into that further where you can actually read that. That is a useful piece of information whenever you're doing calculations later on. And here's an example of these guys coming in. Okay, here's your low voltage. They're not showing the black, but here is your red, blue, and your neutral in the back. Okay, your intentionally grounded conductor. And here is a example of a high voltage or 480 volts. Okay, brown, orange, yellow, phase A, phase B, phase C, and the neutral there. So let's get back to this. Rated voltage, got a proper type of wire, whatnot. Method of marking, okay? Single, the following conductors or cables shall be durably marked on the surface. And it goes down through here. All of these things: irrigation, tray cable, underground feeder, service entrance, non-metallic sheath cable, NA cable. Okay, that's your Romex. Single conductor, that's your just regular THHN single wire. And talking about that, all of these things have got to be marked in the same method as these up here for 310.8. AWG size in the circular areas shall be repeated at intervals of not less than 24 inches. I actually had somebody put this as a code question whenever I took a test, and I had to dig and dig and dig to find this because they asked what code reference it was. And I had to dig and dig, and just, it's hard to remember everything, but you just got to kind of remember where things are. AWG size in circular mills shall be repeated at intervals of not exceeding 24 inches. All other markings shall be at intervals of not less than 40 inches. So basically, your size on all these wires are there every 24 inches. The other markings, as far as the type of wires and everything else, are really not supposed to be on there, except are not required to be on there, except for every 40 inches. All right, guys, well, we've hit the end of another lecture. This is our Wednesday lecture. I'm going to close this out again, telling you guys that I realize that some of the links on the page are not working whenever it comes to your landing page or home. That is my fault. I'm having problems getting these things to load up from remotely. And it's, bear with me. I'm trying to get this to where it's going to work for everybody. If we continue working our method, it seems like everybody's seeing my videos. You're answering questions with them, so that just lets me know you're actually seeing them. Again, I've been teaching guys a long time how to be electricians, but actually in the setting like this, in the college setting as it is that we are now, it's new to me. So bear with me. I'm human just like everybody else. Another piece of information: if you're not able to make it with before the assignments close out, okay, reach out to me. Let me know what's going on. You've had an emergency. Something's come up. I want you to be honest with me. I make exceptions. I can extend things if I have to, but not getting to these things and answering these questions just because you just didn't get time to won't work. Okay. Again, we can all do this. We can get through this. I'll look forward to seeing all of you guys in, or at least some of you in my on-ground classes. Again, this is your Hillbilly Professor signing off. Thank you very much.